Okay guys, so in this video what I'm going to do is I'm going to show you how to convert a decimal number into binary in a very quick manner. If you can divide by 2, then you can do this. So I'm going to have about 3 examples through the video, each of them getting a little bit more complicated as the time goes on, that is. And at the very end, I want to show you one neat little trick depending on very specific decimal numbers that you get. So what you've got to remember when you're doing this process, everyone, is that you're actually converting from what's called base 10, that's your decimal numbers, into base 2, into your binary numbers. That's pretty important because this is where the divide by 2 comes from. Let's say for a very first example that we've got the number 14 and it's base 10. That's what the little 10 there indicates, that I'm in decimal. And I want to convert that to binary. So let's take the number over here and let's start dividing him by 2. Okay. So if I divide 14 by 2, I get a whole number of 7 and I get a remainder of 0. Now, it's a really good idea to make sure you maintain these 3 columns. You've got your division, your whole value, and your remainder. And when you're going to continually do this all the way down the page, when you know when to stop is when this whole number gets to 0. So take 7, put him over here and divide him by 2. You're going to get 3, remainder 1. Take the 3, divide him by 2, you get 1, remainder 1. Again, we've still got a whole number there, so 1 divided by 2, which sounds silly, but then we get 0, remainder. Okay, and you can probably see, this is our stopping condition when we get to the whole value of 0, that we've actually got a binary sequence going on over on the side here. Now, we don't actually read this top to bottom, we read this upside down, bottom to top. And the way you write your answer is you go, therefore, 14 base 10 equals 1, 1, 1, 0 base 2. Okay? So that is 14 in decimal into binary. Okay? I'm going to do a quick proof just to show you how this actually works. So let's scroll down the page a bit. These are my binary numbers here, 1, 1, 1, 0 base 2. That's all well and good. How do we know that's actually 14? I'll give you a quick heads up for the next video. Each binary bit has got a value. In this case, it's 1, 2, 4, and 8. Now, if I grab those 3 numbers, 8 plus 4 plus 2, the answer is 14. Okay? So that's how I know it works. So let's do another quick example. Let's do a bit of a bigger number. Let's do 37, 10, and let's start our division. So 37 divided by 2 is 15 plus 3. Okay, that's 18, remainder 1. Let's do 18 divided by 2 equals 9, remainder 0. 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. 1 divided by 2 is 0. There's our stopping condition. Read it upside down, you get, therefore, 37 base 10 equals, read it from this direction up, guys, 1, 0, 0, 1, 0, 1 base 2. Okay, and there's your answer. Now let's step it up a little bit more with the last one and finish up with on this note. Let's do 103 base 10. Okay, and let's convert him. 103 divided by 2 equals 51, remainder 1. Okay, 51 divided by 2 equals 5. 1. 5 divided by 2 equals, excuse me, 12. Remainder 1. 12 divided by 2 is 6, remainder 0. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is our stopping condition because it's 0, remainder 1. Should always end up with. Read it upside down. Got a therefore 103 base 10 equals 11001111. Bang on. Now, when you get to this size binary strings, it's actually somewhat a good idea to start grouping them in 4s. So I would actually, in my class, start spacing them out. Okay, it doesn't make any difference to the value. We just add a little bit of a gap in the middle there just to make it look a little bit neater. All right, that's pretty much all the examples for this one, but I'm going to show you a couple of tricks. Okay. Now, The first trick I want to show you, let's say I have the value, well, let's say 63 base 10. If I want to convert that to binary, I can tell you without even doing my divisions, okay, that it's going to be that. Okay, and then I'll try another one for you. 127. I can tell you is 1, 2, 7. Ones in a row. Okay, and the way I know that is because this little trick here, and if it doesn't make sense, don't try and remember it. I go 1, 2, 4, 8. I'm going to run out of space. 16, 32, 64. Okay. Now, if I was to double 64, the next value would be 128, which is, as you can tell, one number underneath 127. So that means we need all these ones here to make up 127 before we touch 128. Okay. Same thing with 63 up here. Okay. It's 1, 2, 4, 8, 16, and then 32. And the next value would be 60. So if I want to get 63, I just put 1, 1, 1, 1, 1. Right, now, if that did not make any sense to you whatsoever, don't worry about trying to remember it. Just do the divide by twos. Okay. And hopefully now you know how to convert a decimal number into binary.